everybody. Reporting to you again from the Glamour City, Hollywood.
Yeah, I think we're seeing this on land and in the oceans, where warming increases the sort of abundance of parasites and of pathogens that potentially cause human disease, but also are just not good for the animals as well, right? And so there's an animal welfare and a human welfare component to the impacts that we're having on our food system. I think there's also been a very long running discussion about heavy metal pollution in fish, particularly in fish like tuna. But even if you look at farmed fish, a lot of these farms are located in river deltas or in bays where rivers that have lots of heavy industry upstream are emptying out into these bays where fish are farmed. So you're seeing increases in cadmium and other heavy metals that are byproducts of some of these production systems also ending up in our foods, not to mention all the microplastics that we're finding in everything, including in our fish. So I think there's a lot of reasons to want to try to make some changes to what we're doing today.
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for our show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Mihir Pershad, founder and CEO of Umami Meats. Welcome to the show today.
Thanks for having me.
All right, so let's get a big picture of how is climate change and overfishing impacting seafood?
So there's a combination of oceans warming and getting more acidic that's really helping to drive a lot of species to much less sustainable population levels than they already are. And then this is compounded further by humanity wanting to catch more and more fish every year to consume. And so populations have been in serious decline for the last 40 years plus.
So we may come back to the climate change impact a little bit later, but let me ask you a follow-up question, which is, why isn't farming fish the answer for everything? Why are some fish difficult to domesticate?
So there's a few reasons for that. I think some are biological. We just don't know how to breed them or what to feed the youngest animals, the juveniles. And this is often the biggest bottleneck in producing new species for farming. And then in some cases, it's just pure economics. So for example, we can farm tuna in some cases, but how much feed you have to give them is often about 20 to 22 kilos of wild caught fish to feed a tuna until it's ready for harvest. And so the economics on that don't work. And it's also still pulling an increasingly scarce species out of the ocean to feed a farmed fish. So this is often an issue for carnivorous species.
Mm-hmm. Yeah, it makes a lot of sense. And what is IUCN red listed?
So the IUCN is the International Union for the Conservation of Nature. It's sort of like a UN-esque body for governments and NGOs that come together to monitor the status of animals worldwide. So they're sort of the leading authority on putting animals on the endangered list or on the vulnerable list. And the red list are the most critically endangered and endangered species.
Gotcha. So let's get into your organization that you created, Umami Meats. What is it, and what are you guys doing specifically in this area?
Yeah, so Umami Meats is a cultivated seafood company. So our mission is to enable cultivation or using cell culture to produce fish for species that are endangered and that are being driven to extinction because humans want to eat more of them than we can get sustainably from the oceans. And so our business is to create the underlying technology, we call it sort of the Cultivate OS, that will enable the food industry to produce fish to feed the population from a more sustainable local production source using what's essentially beer fermentation as opposed to catching out of the oceans.
All right, so now it's interesting because you have a focus which is on the endangered species and overfish, including the Japanese eel as well as the yellowfin tuna and the red snapper. And I wonder if you give us a rationale as to why you decided to prioritize on those particular types of fish.
So our strategy was initially coming in, looking at this IUCN categorization and identifying the species that are at substantial risk of being driven extinct by human consumption. We then layer on top of that the species that we can't farm. And then within that subset, that gives us about 24 species to work with. And so then we looked at what is actually something that's easily available to us based in Singapore, and where is there growing demand? Because those seem like the biggest levers that we could create good markets for and also still have a strong environmental impact. And so if you look at a species like eel, it was a very obvious choice for us because the population has been cratering for more than a decade. The prices have doubled in the last half decade, and demand is not really moving. So it's very clear that people want to eat this fish regardless of how much is available. And so we saw similar trends in tuna. I think tuna is a little bit of a different species or group of species because there are 4 or 5 that we eat, different kinds of tuna. And some of them are more sustainably fished than others, but broadly they're heading in a very worrying direction because the volume has been just consistently increasing.
Now, on the eel, it's interesting because I think for our U.S. listeners, some of the listeners may never actually had any eel before. That is more of a delicacy within, let's say, the Japanese or the Koreans, for example. So how big of a market is that, and is that worth pursuing, given the fact that many of them are also farmed as well?
Yeah, well, so I think interestingly, you bring up the farming of eels. So they're actually what we call ranched because you still have to catch juveniles in the wild. And at the stage, they're called glass eels. They're about 3 to 5 cm long, and then you fly those over to a place where they're grown to adult market weight. And so actually, in some ways, this is worse than a traditional wild catch sort of system because you're catching animals before they get to reproductive age. So there's no chance for the population to actually rebound when you're catching juveniles very early in their life cycle. But eel, I think, is surprisingly to a lot of people pretty substantial market. So predominantly, as you mentioned, Japan, Korea, but also Northern Europe and sort of Germany, Denmark. They have a smoked eel that's more common as a food. It's about a $4.5 billion market globally, and it's about 500,000 tons of eel that gets moved every year. So it's a fairly substantial market. I think sometimes it's hard to put into context massive numbers like our seafood industry, which is 100 million, 120 million tons of fish a year. So even if you're talking about 500,000 tons, right, it's still a very substantial volume, but it's a tiny fraction of the global seafood industry.
And going back to the yellowfin tuna, it's something that we've known for some time in terms of the deterioration of that particular population, as well as just overfishing. But you have big market players, including manufacturers and distributors, without mentioning who they are, that depend on it. And I wonder, how do they perceive the likes of alt meat and cell-based substitutes coming into the market?
I think it varies quite heavily kind of company to company in terms of perception to, let's call it, potentially competitive technology and production methods. So you see some companies, and Thai Union is a very visible example of this. They've set up an alternative protein innovation center outside of Bangkok, and they're investing heavily in plant-based, cell-based, and in partnerships to basically help them to produce more than they can produce sustainably by fishing. And I think then there's some companies that still think that fishing is going to be the predominant way that we produce in 20 or 30 years. And so they're still betting quite heavily on that. And still others are investing diversification into land-based RAS systems or recirculating aquaculture on land, which is stable, but still very expensive and low volume relative to what we get out of the oceans. So I think there's really no one point of view in the industry. But I think the most forward-looking companies realize that nothing lasts forever and that there is a natural transition that will happen. And if they want to invest in it early, it can be complementary to their business in the short term and help them to also then position their products in a more sustainable way in the long term.
Now, for anybody that is a Japanese sushi lover, they know that that type of fish is hard to get, and actually they're imported specifically from Japan. You can't just go to Whole Foods and expect to have sushi or sashimi ready types of fish. So it is a very much a specialty, and the price keeps on going up. So that makes a lot of sense. Now, the other thing that I think is a concern for some of those, including myself, is I've started to eschew sashimi because of the fact that rising temperature in the oceans, rising the level of bacteria, and so forth, it means that potentially the kind of fish that I eat, especially if it's raw, it can be dangerous, not only in terms of the potential chemicals that's inside, but also the bacteria as well as the worms inside.
That's right. Yeah, I think we're seeing this on land and in the oceans where warming increases the sort of abundance of parasites and of pathogens that potentially cause human disease, but also are just not good for the animals as well, right? And so there's an animal welfare and a human welfare component to the impacts that we're having on our food system. I think there's also been a very long running discussion about heavy metal pollution in fish, particularly in fish like tuna. But even if you look at farmed fish, a lot of these farms are located in river deltas or in bays where rivers that have lots of heavy industry upstream are emptying out into these bays where fish are farmed. So you're seeing increases in cadmium and other heavy metals that are byproducts of some of these production systems also ending up in our foods, not to mention all the microplastics that we're finding in everything, including in our fish. So I think there's a lot of reasons to want to try to make some changes to what we're doing today.
So I really like the fact that you bring up some of these points, and this brings us to your methodology of how you're taking sample from a fish, extracting the stem cells, and have then turning that into the muscle fat to create the final product. Can you talk about the process of the harvesting, establishing the stem cell line, the culture, and so forth?
Sure. So we take a sample, usually of about 1 to 5 grams. So it's very small from a fish, usually of muscle tissue. And then we're able to isolate stem cells from that. And those stem cells, in our case, are kind of a unique type of stem cell that can produce muscle, fat, and connective tissue, all from this one stem cell. So we are then able to grow this stem cell up in bioreactors, which look a lot like beer fermenters. We actually call them, fish cultivators. And we then turn these cells into muscle and fat, harvest them down, and produce various structures of seafood downstream. So we can produce raw grades for sashimi and sushi, but we could also then produce value-added products like battered fish for fish and chips or fish cakes or the many other ways that people consume seafood today.
And it's important to note that in this process, this culture process, you're not replicating or trying to create those chemicals or heavy compounds or the kind of parasites or the bacteria that we're talking about. We're talking about really clean meat, right? And how do you ensure that it's clean throughout the process?
So I think one of the benefits and one of the risks of this production method is that if you're growing things basically in a large steel tank, right? So it doesn't have an immune system. So if you do have contamination, your batch is going to get ruined, and so then it won't get served to people in the first place. And so we have a direct interest in making sure for process control that everything is as clean as possible. And that translates into a clean end product that's doesn't have heavy metals, doesn't have plastics, and doesn't have the parasites in it as well. So some of that is it's almost a byproduct of the production method that we have to keep it to that level of standard for us to be able to manufacture it all.
Now, one of the kind of the secret to your IP is this notion of SelfFoundry process in terms of how you guys model, validate, and optimize the cultivation process. Can you go into a little bit more depth?
Yeah, so I think there's been a bit of a revolution in cell screening and development in general that we've seen come from cell therapy and other kind of biotech applied to human healthcare. And that's coming into the food system. So you see most companies are working with robotics and some sort of automation to help them screen more conditions to find the optimal growing conditions for the cells for fish or cows or whatever meat they're trying to produce. But the real challenge is that this is sort of a blind screening process. You're trying to sample many, many different options within a large space to find the optimum condition. But it gets more and more expensive linearly the more conditions you screen. So our thought process was machine learning has advanced so much in the past few years. Could we apply machine learning to the data that we're gathering about how well the cells grow in different conditions and start creating a predictive model that helps us to test fewer conditions in the lab while testing more of them computationally, and basically creating a directed process where machine learning is helping us to do more efficient screening. The long-term vision is this also helps us go from an eel to a grouper or to a flounder and learn how to transfer the optimal condition knowledge between species so that we can really create a much faster path to market for the many species that we want to work on over the next decade plus.
And really, what you're talking about is actually very, very sophisticated. And I know there's a MIT spinout, actually a Harvard spinout that's working on this as well. That's really gotten a lot of attention, particularly using laser optics to control some of these things. The better the computation, the better the analysis means that you can actually laser focus on the cells that you do want to replicate, and they eliminate the ones that are not correct. Is that right?
Yeah, and I think it's not even just the cells you want. It's also a lot of work's been done on human cells, on mouse cells for human therapeutics work. And so those model systems are relatively well understood. But when you start talking about what do you feed a fish cell and what's the optimal temperature and what's the optimal density that they like to grow at before they get too crowded and then stop growing well, these are all questions that are very much in a black box when it comes to new species. And in particular, endangered species in fish have not been particularly well studied, even compared to things like salmon that have been farmed on a large scale, and the research is much more robust. So we have just a massive space to explore, and I think it's fundamentally not going to be feasible on the budget and timelines we have without having computers help us see patterns that we don't see ourselves.
Well, that's interesting because now you're starting to talk about the value of the data itself and how data specific to the species is really the value in itself, correct? And if you have a better, richer data set than a competitor, you're going to be able to have the right sets of boundaries, conditions, and filters to get the results and the output that you want quicker.
I think that's right. And I think there's also value that we don't yet know how we develop it. But for example, one of the core challenges for an alternative protein company is not just producing a product, but producing something that matches the nutritional profile, the flavor, and the texture that a consumer expects. And it doesn't necessarily need to match the traditional product one-to-one, but it needs to provide the right experience so that somebody chooses to purchase it over an alternative. And that same information helps us figure out how to grow the cells, right? The flavor profile is also the nutritional profile in many ways. And so for us, the question is, how do we take this knowledge later on and translate it into better tasting, more nutritious products as well?
It's very interesting. At the time of the recording of this interview, there was a Nature article that came out that talked about the importance of seafood in particularly and how that particular research looked into specific species that had higher nutritional value and how consuming more seafood relative to reducing, let's say, land-based meats like cattle and pork and chicken and so forth is actually going to mitigate climate change more so. So clearly what you're saying makes a lot of sense. Now, with that said, one of the challenge, of course, is kind of this notion of structure. And I know there's been a recent collaboration announced with Meotech 3D that provides 3D printed cultivated structured seafood. I wonder if you could tell us a little bit about that.
Yeah, and they've actually just recently rebranded to Stakeholder Foods. But we've established a partnership with the goal of exploring a number of different technologies. And in this case, the partnership with Stakeholder Foods is to look at 3D printing for structured products that would be cooked or raw. So both for the sashimi grade as well as for whole thick cut fillets. And in our case, the strategy here is that we want to really own inputs to production of cells as a mass production system. And we want to then partner to explore how different production formatting technologies or structuring technologies can help us create a breadth of products. Because as you might imagine, you trying to create something that would be optimized for sashimi may look very different from trying to create a tuna steak that's going to get seared on an open flame. And in our view, the 3D printing creates potential to create many of these thicker cuts that have much more texturization to them in a way that is currently not achievable with existing technologies. And the thing we're most excited about with this partnership, I think, is the throughput potential. We think Stakeholder Foods is really onto something with the volumes they can do 3D printing at. And we're talking about being able to match a multi-ton scale production line with 3D printing capacity, which would be revolutionary compared to the current state of 3D printing.
So I want to talk a little bit about the fact that this particular partnership, but also in general, is that you have other competitors. So if you could talk about how other competitors are different, wild type, blue nalu, aquaculture foods, to name a few. Why is your methodology different from theirs, and not necessarily saying better? And then are they also tapping into the same level of ecosystem partners and 3D printing providers?
Sure. So I think there's a couple of different approaches being taken in our system. The vast majority of companies in seafood and meat are working with muscle stem cells. And so those are stem cells that are already preconditioned to turn into muscle. And with quite a bit of effort, you can theoretically turn them into other things, but they've already sort of genetically decided that they want to become muscle. And so those have some inherent disadvantages, we think, in terms of doubling time and in terms of longevity of the cell line, compared to the stem cells that we work with that we've been able to grow for over a year continuously. So our thinking is that the cell types have an advantage kind of structurally, if you will, embedded in the genome. But then also when it comes to production, we can leverage the fact that we only need to get one cell line qualified through a regulator up. We only have to optimize the system around one cell line and then can turn it into muscle and fat. Gives us some advantages because it just means less work overall to get to a commercially ready system compared to if you need a fat progenitor and a muscle progenitor that'll both have to go into your production unit separately. There's also some downstream benefits in terms of lower cost of goods and lower capex investment required, because you can use a single production line instead of multiple in parallel to generate your cells for fish cell mass. And when it comes to strategy, I think we also are relatively separated from most companies in our space in that we're taking a very B2B approach. So our strategy is very much build the operating system that enables the industry to move as quickly as possible to cultivated seafood relative to trying to produce our own brand, for example, and then work with existing distribution. I think that's driven fundamentally by recognition that this industry is massive. Right? We talk about food that touches every person on the planet, and 150 million tons of it is consumed every year. And there's not really a way that we can see to produce 150 million tons on our own. And so trying to work with the traditional seafood businesses to help advance kind of the state of technology as quickly as possible, we think puts us in the best position to scale quickly. It also puts us in the best position to launch in many markets without having to try to really learn from step zero. How do you market in a different language? What do consumers in this country care about? We can work with local partners who know that already. And I think that's going to be a big advantage for us as well.
Well, I think one of the things that we talked about before is that the final products come in many different forms, from let's say fish balls to tuna steaks, but even fish sticks, and the varieties and the formats really vary by region and geography and cultures. So to be able to have all those different derivatives, really, that would be just overwhelming to be a B2C company. Moreover, I think given the recent supply chain issues, I think a lot of the manufacturers that are creating these finished products are recognizing that they need to have a wider source of different vendors, including your sources, in the case of disruptions, for example. Which brings me to the latest product that you guys have launched, which is a cultivated fishball laksa in a spicy noodle dish. To me, it's very intuitive as to why you guys went that approach first, but if you could talk a little bit about that product.
Yeah, so this was, we ended up doing a public launch actually at a relatively large VIP event that was supported by a couple of ecosystem partners in Singapore. And knowing that we were doing our first launch in Singapore and that we were developing our company, we wanted to do something that was culturally tied into traditional Singaporean cuisine. And laksa, I think, is one of those dishes that if you think what's a Singaporean food that's sort of iconic and very historically embedded in the culture, laksa is one of those things, along with like chili crab and a few other kind of dishes. And so to us, laksa made a lot of sense just from a cultural perspective. And I think at the end of the day, we're developing food and it needs to resonate with people. And so those were a couple of the reasons that led in that direction. It's also in some ways a pathfinder to solve one technical challenge at a time. So we were able to produce lots of fish cells so we can make a fish ball. Now we have to work on more structure and different kinds of flavors and before you can do something like a fish fillet. And so we're trying to basically work on these prototypes in a way that allows us to solve one or two problems at a time, as opposed to having to solve all of them to put a tuna steak out as the first prototype, for example.
And I think the other thing that it's important to note is that while other competitors are fully focused on cell-based, you recognize that there's also certain characteristics, flavor profile, nutritional aspects, and textures and so forth you talked about that can only be provided through other means. So in this case, with the fish ball, you decided to actually also incorporate plant protein as well. I wonder what the thought process was there, and can we anticipate plant protein also as part of the ingredient for your future products?
Yeah, so I think in some ways we are a technology providers, but in other ways we can be a sort of an ingredient enabler. And so we're trying to experiment with the different applications for how fish cells could be used to produce products that we haven't seen before, in addition to the ones we know and love. And I think there are opportunities, particularly when it comes to producing hybrid products where fish fats and some fish cells can create enhanced nutrition and flavor for something that is also much more affordable. Because in some cases, seafood can be a very premium product in many markets. And so we think that's a really interesting application. And our capacity to produce fish muscle and fat with our technology makes that an interesting option to explore, especially in countries with lower purchasing power, where 100% cultivated product may not be viable in the market day one. Mm-hmm. And in the case of the fish balls, so fish balls are traditionally 40 to 50% fish, and the rest of it is things that hold the fish ball together. And so it was very natural for us to look at a hybrid type of product in that case, because you actually couldn't make 100% fish ball hold together if you dropped it into to boil it. And so some of our upcoming prototypes will also be hybrids, and we'll also then be demonstrating some 100% fish cell prototypes interspersed there as well. So really trying to focus on breadth of potential and explore maybe what makes the most sense for each application.
Makes a lot of sense. Now, the last question I have for you is consumer acceptance. Consumer acceptance, and certainly both also the industry as well. Certainly on the cattle, for example, there's a huge lobbying effort by traditionalists to reduce, block, mitigate cell-based labs foods. In the case of seafood, for example, what are some of the biggest barriers? So, for example, we talked about fish balls, but when we talk about century-old Japanese sushi places where they are generation 3 or 4, and they are used to a certain technique, and they're very choosy about the selection of fish from where in a particular ocean or sea, are they going to accept the sashimi that's going to come from you guys?
So I think this is an ongoing and evolving conversation. We've actually done some consumer perception research very recently across Asia in local languages. And we found some interesting correlations. The biggest amongst them was that the more educated somebody was about cultivated, the more likely they were to have positive associations to health and environmental benefits. Whereas people who had never heard of it before were more likely to have skepticism around the product or whether they could see themselves eating it. And so I think part of this is communicating why it's important that we have more diverse production systems, where the challenges are with our current production today, and why we need to change, at least in some ways, what we're doing. And part of our strategy with focusing on these endangered species that we can't farm is that there's very clear past history as well as future trajectory about what's going to happen to these species if we keep doing what we're doing. And in many countries, I think there's a deep-seated desire to sort of think about, what does this mean for my children's generation, for future generations, preservation of a way of life. And in some ways, that's something that we can offer that's pretty unique, which is that if you continue to eat eel, as an example, at the same rate we eat now, kids who are born tomorrow won't see eels by the time they're adults, probably on plates. But if we introduce cultivated products into the market and take sort of a eat one and then eat one cultivated approach, this can help to preserve species for the long term. And different things resonate with different people. I think health risks and health concerns about wild caught fish are more and more prevalent than ever. And I think we're also seeing more environmental thinking, driving decision making with consumers. And so in our view, it's a lot of it is perception, and then trying to be as transparent as we can with consumers so that it doesn't feel like there's this new black box around food, because that's never something that we want people to feel.
Well, thank you so much for that. I have been joined by Mihir Pershad, who is the CEO of Umami Meats. Thanks for joining today.
Yeah, thank you very much.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.